For this assignment, you're going to be looking at the electronegativity of different elements. We've already kind of looked at these before when we did the trends of the periodic table, but now we're going to look at it in terms of bonding. So we have three types of bonds we can talk about. Polar, which is when the difference in electronegativity is between 0.5 and 1.7. Nonpolar, which is if the change in electronegativity is less than 0.5, and if 1.7 is less than the electronegativity, so in other words, if this is larger than 1.7, then it's going to be an ionic bond. So these are our three trends we're going to look at. If you want to put that at the top of the sheet, you're more than welcome to. I will provide this when you have the assessment over this though. So what we're going to do is we are going to take the values for each element and subtract them to find out what our change in electronegativity is. So CS is 0.79 and BR is 2.96. So I'm going to go ahead and put the bigger one on top, and I want to subtract those, and we'll get that value. Okay. And what I want you to do is go ahead and do the same thing for all the rest of these. 3.44 minus 3.44. That one's going to give me 0. So since that one's less than 0.5, this one will be nonpolar. Okay. And then you're going to continue on. S is 2.58 minus H, which is 2.20. If you look to see which one's larger, put the larger one first, because you don't want to have a negative here, because a negative we can't reflect up here. Otherwise, take the absolute value and just consider it a positive value. So here we would have 0.38, which if we look up here, that's less than 0.5, so that one's also going to be nonpolar. Okay, Ca and O. Ca is 1, O is 3.44. And we get 2.44, which is greater than 1.7, so this one's going to be ionic, which if you look at those, Ca is a metal, O is a nonmetal, so it would make sense for that to be ionic. Okay. This mainly helps for the ones that are kind of in between where there's no definite answer. So 3.16 for Cl, and we've got 1.90 for Si. That's going to give us 1.26, which is going to be between here, so that one's going to be polar. Okay. This one, if we put that in a calculator, we get 2.17. That's going to be greater, so that's going to be here, so that's going to be ionic as well. As and P above and below each other, so 2.19 minus 2.18 equals 0.01, and 0.01 is going to be here where it's less than 0.5, so that's going to be nonpolar. And then we've got C and O, so we're going to have 3.44 minus 2.55. Those are coming right off that periodic table. And we would have, that'll give us 0.89, which is going to be between the 0.5 and the 1.7, so that one's going to be polar. Now, if we had to rank these, and H, we're going to have 2.2 minus 2.2, that one's going to be nonpolar, because it ends up being 0. Now, if we had to look at these, so ionic is going to be the biggest difference in charge, because that would be like your Na plus and your Cl minus. Your polar is going to be where there's a difference in charge, but it's not the ionic. These are strictly ionic, where it's giving and taking the electrons. Polar is going to be where one element is going to attract them more than the other, so then there's that slight charge. So for Si and Cl, so one's going to attract the electrons more than the other, and we would have a partial positive and a partial negative on those two elements when we make the bond. And then the nonpolar just means that there's not enough difference in the charge of the atom in order to make it polar. So in the cases of oxygen and oxygen, or H and H, hydrogen and hydrogen, those are going to be nonpolar because the electronegativities are the exact same thing. So here you can determine the degree of polarity for these and put them in order. And then how does an element's electronegativity relate to its position on the periodic table? So think about the trend that we talked about with these. When you're ranking these in order, you're going to put them in order for polarity. So you're going to list the nonpolar first, and then go polar, and then go ionic. So basically you're going to be going from smallest difference to largest difference in the electronegativity values. So you can finish these 2 questions and then you can go ahead and move on to the back. There might be a couple of these that are actually the same as the other side, but go ahead and work through these and figure out your difference in electronegativity and the bond type. I do have a spot for you to write down the electronegativity for each one here, and then you should be able to figure out whether it's going to be nonpolar, polar, or ionic.